In my previous examples, my polynomials have always been linear pieces. And that was nice because if our polynomial is a linear piece, then when you take the derivative, it becomes a constant number. Well, what if our polynomial is of higher order? That happens here in example 3. We have a quadratic polynomial of 12x squared multiplied times an exponential e to the 2x. Let's go ahead and integrate this. We need to, once again, decide what our f prime and our g are in this integration by parts formula. F prime in this case should be the exponential function. We've said that, and anytime we have a polynomial times an exponential function, the exponential function becomes our f prime, the polynomial becomes our g. When I take a antiderivative to get f, I need to take 1/2 e to the 2x. When I take a derivative to get my g prime, I get 24x. Notice what that is going to force in this formula. It's going to force this integration to be equal to f times g. I'm going to multiply f times g. 12 times 1/2 becomes a 6. I end up with 6x squared multiplied times e to the 2x minus my integration of f times g prime. Again, I'm going to multiply this. 24 times 1/2 becomes 12. I have an x and an e to the 2x. As you can see, this piece is just fine, but this piece, once again, is a polynomial times an exponential function. That polynomial times exponential function, just like this, is going to cause me to do another integration by parts on this piece. So we are going to do another integration by parts on this piece. Before I do that, I'm going to set it up just a little bit different. I'm going to take the negative sign and place it on the inside. I think that's a little bit easier because when I do my second integration by parts, I want to be able to deal with a plus sign here. It's not a big deal if you don't do it this way, but there you go. F prime we set as e to the 2x. G would be equal to negative 12x. Again, what I'm doing is I'm just doing the integration by parts on this second polynomial, a linear piece times e to a power. My function f would have had to have been 1/2 e to the 2x, that's familiar. G prime would have had to have been negative 12. Now, when I'm doing my integration by parts here, this fg minus integration is just replacing the integration component here. The 6x squared e to the 2x is going to maintain its role in front. So when you set this up, you're taking this integration, just the second integration, and replacing it with and FG. In this case, let's multiply this out. Negative 12x times 1/2 e to the 2x gives me negative 6x e to the 2x. That should be a minus there, not a plus or minus, but a minus. Minus integration of f times g prime. Well, f is 1/2 e to the 2x multiplied times g prime is negative 12. I end up with negative 6 e to the 2x. Notice what I did there. I did an integration by parts on the second component. And when I did this twice, all of a sudden, I got down to having my polynomial just be a constant number. In this case, that number was negative 12. I can rewrite this a little bit. I have a minus times a minus there. I'll do a plus instead. Now I can integrate. My answer is going to be 6x squared e to the 2x minus 6x e to the 2x. And when I integrate this thing, what I'm going to get is 6 over 2, which is 3, multiplied times e to the 2x. And I have to tack on a plus constant. Notice what happened here. I had started with a quadratic polynomial. When I did one derivative, that got me down to a linear polynomial. And when I did a second derivative, it got me down to a constant. So I did a first integration by parts, which was my original integration. And then I did an integration by parts again on the second integral. When I did that second integration by parts, then I was left with something that I could integrate directly using my basic rules. And when I integrated that thing directly, I got this. If you want to talk about what's happening, basically, if you took a derivative, you would get two parts, we'll call them A and B, from this first component using the product rule. You would also get two parts from the second component. One of them is going to cancel out with your B, and then you're going to get a new part. And then from this third component, maybe I should write D instead of C because I use C for constant. And this third part is going to be a negative of this. So you're going to get 5 terms, and I'm going to have 2 pairs that cancel, and I'll be left with a single term. And that single term happens to be what we were looking for at the very beginning, 12x squared e to the 2x. There we go. What I would like you to do is to use integration by parts to integrate the following function. We have here a quadratic polynomial multiplied times a trig function, in this case, multiplied times sine. Go ahead, push pause on this video, and try this problem on your own. Because you have a quadratic polynomial, this is going to require 2 integration by parts in order to do.